Okay, doing a brief introduction into acids and bases here. First off, there's a couple different definitions with acids and bases. The first definition is the Arrhenius definition. Svante Arrhenius was a famous chemist in the late 1800s who had came up with the definition, the original definition of acids and bases. And he had said that an acid is a substance that when it's dissolved in a solution, it dissociates into hydrogen ions, okay, and then a base is a substance that when it's dissolved in a solution it dissociates into hydroxide ions. That definition was later updated to say, it could be hydrogen ions, but more likely it's going to be what's called a hydronium ion. That's what H3O plus is. It's a hydronium ion. Reason for that is because if we have a hydrogen ion, and we combine that with water. Water, of course, has two hydrogens, so that's going to give us three hydrogens total. So we have H3O plus, and that is our hydronium ion. So that is the definition as it stands today. That's the first definition. This is a quick, easy way to determine if something's an acid or a base. It's not going to be right all of the time, but you'll be right about 80% of the time. I have some compounds down here that we can look at, and why don't we do those right away? Just by knowing what we know here, we're looking for a hydrogen ion, okay, or a hydroxide ion in the formula, and that way we'll know if it's an acid or a base. So the first two, as you can see, there's hydroxide ions in there, so these are going to be bases. Second one, there's no hydroxide ion, but there's a hydrogen ion, so that's going to be an acid. And then our fourth one on the bottom here, trying to think what this is. Should have written it out this way. Be a little easier to read this way. Okay, that's acetic acid that we have here. And what let's look for hydroxide ions first. Do we see any of those? Nope, no hydroxide ions. But then hydrogen ions. Of course, there are hydrogen ions there, so that's going to be an acid. Okay. So like I said, that's a quick, easy way to determine if a substance or a compound is an acid or a base, but it's not going to be correct all of the time. It's going to be correct most of the time. A more accurate definition is the Bronsted-Lowry definition, and that says that an acid is a proton donor, and essentially that is what's happening in all of these. And a base is a proton receiver. Okay. What else did I want to talk about here? I think that was really about most of it. So that's just a brief introduction. Of course, I'm not going to get into too much about the proton donor and proton receiver, but you should know at this point how to do chemical formulas and how to read them, how to write them. So that should make sense. We'll have some more videos where we'll do examples of that, but I just want to let you know that that is the Bronsted-Lowry definition, and that's a little more accurate of a definition. What else? There's strong acids, there's weak acids, there's strong bases, there's weak bases. Essentially what it's saying is that if we have a substance, for example, hydrogen chloride, we know as an acid, because we just determined that. But is it strong or is it weak? Well, it's strong because it dissociates 100% when you put it in a solution. Okay. There are some acids out there that are going to be weak acids because they don't dissociate completely. They might dissociate at 50% or maybe 40%, and that's what makes them a weak acid. Okay, I think that's about it. Like I said, it's a real brief introduction into acids and bases. There will be more videos on this, talking about pH and that type of